Welcome to the RHEL10 Security Hardening Lab. In this session, we will harden a Red Hat Enterprise Linux 10 server to meet global security guidelines, the CIS benchmarks, the DISA STIG, and NIST 800-53 controls. The good news, RHEL10 ships the exact tooling Red Hat recommends for this, OpenSKAP and the SKAP Security Guide. So we will scan, remediate, and verify using the same standards auditors ask for. By the end, you will know how to take a fresh, exposed server and prove it meets a global baseline. Here is our lab environment. You are the new sysadmin. Web01 is a fresh RHEL 10 server hosting a web application, and it is directly reachable from the internet. The baseline is weak. SE Linux is permissive. The firewall is not running. Root login over SSH is enabled, the password policy is the default, and there are no audit rules. Your compliance officer has asked for hardening evidence against the CIS Level 1 benchmark for RHEL 10. Your mission: take Web01 from a failing score of about 45% to 90% or better, using the official SCAP content, then verify every control. Step 1. Record your baseline before changing anything. Confirm the exact release with cat/etc/redhat-release. Check SE Linux mode with get enforce. Note that it says permissive. Check the firewall state with firewall-cmd-state. Inventory what is listening with ss-tlnp, and list enabled services with systemctl list-unit-files. Then, and this is critical, take a snapshot or backup of the server. Hardening makes many changes at once, and OpenSCAP remediation is not easily reversible. Your snapshot is your safety net. Write down your starting compliance score. You will compare it later. Step 2. Install the compliance tooling. Run dnf install-y, scap-security-guide, and OpenSCAP-scanner. On RHEL 10, DNF5 handles this. The package installs the data stream ssg-rhel10-ds.xml under /usr/share/xml/scap/ssg/content. Now inspect it with OSCAP info. This lists the benchmark profiles: CIS Server Level 1, CIS Level 2, STG PCI-DSS, ANI, and others. For this lab, we choose the CIS Level 1 server profile, the commercial standard most auditors recognize. Step 3. Run your first scan. The command is oscap xccdf-eval --profile CIS server level 1, and we save the raw results and an HTML report. The scan evaluates hundreds of rules against the CIS baseline. When it finishes, open the HTML report in a browser. You will see the overall score. For Web01, it is around 45%, and a table of every rule with pass or fail, plus severity. Rule identifiers look like xccdf_org.sSG project.content_rule_sshd_disable_root login. Read the failed high-severity rules first. SSH root login, password policy, SE Linux mode, and file permissions. Step 4. Remediate. The SKAP content includes a fix for nearly every rule. Add --remediate to the same evaluation command. OpenSKAP now applies the remediation steps and retests each rule in one pass. When it finishes, the score typically jumps into the 90s. Caution: remediation is powerful and not automatically reversible. Review the report to see exactly what changed and expect a few rules to still need manual attention. Things like crypto policy selection, custom services, or values you must choose yourself. We will cover those next. Step 5. The front door. Create a drop-in file under /etc/ssh_ssHD_config.d. named 99-hardening.conf. Set permit root login no, password authentication no, keys only, max auth tries 4, login grace time 60, and a banner file. Always validate with SSHD-T before you reload SSHD. Then harden accounts in /etc/security/pwquality.conf. Set minimum length 14 and minimum character classes 4. Configure lockout with PAM fail lock. Deny 5, unlock time 900. And set the system crypto policy with update-crypto-policies, choosing default or FIPS for federal environments. Never close your only session. Keep a second console open before you reload SSH. Step 6. The system core. Set SE Linux to enforcing in /etc/SE-Linux/config and schedule a relabel with fix files on boot before you reboot, so file contexts are correct. Next, the firewall. Enable Firewall D. Set the default zone to drop. Deny by default and explicitly allow only SSH, HTTP, and HTTPS. Disable unused services with csteamcl disable -- now. Harden the kernel with sysctl. Enable ASLR. Restrict kernel pointers. Disable core dumps for setuid programs. And enable reverse path filtering and sync cookies. Apply with sysctl -- system. Finally, install AED for file integrity. Initialize its database, then run periodic checks so unauthorized file changes are detected. Step 7. Prove you can see what happens. Enable Audit D and load the audit rules that ship with the system. On RHL, load them with augin rules -- load. Then verify with audit-ctl -s and confirm events are landing in /var/log/audit. Next, configure the system journal for persistence. In journald.conf, set storage to persistent, compress yes, and a size limit. Then restart systemd-journald. Ensure time is synchronized with crond. Audit evidence is useless without correct timestamps. Finally, forward logs to a central log server or SIEM. And once everything is stable, set the audit daemon to immutable mode so even root cannot tamper with the rules. Step 8. Verify and maintain. Rerun the OpenSKAP scan against the same profile. Your target, 90% or higher. Confirm the service still works. The web page loads, SSH login with keys succeeds. Then reboot and recheck that SE Linux is enforcing. The firewall is up and your score is stable. Hardening is not a one-time event. Enable DNF-automatic for security patches. Schedule a weekly OpenSKAP rescan with a systemd timer. Watch the audit log for anomalies and bake everything into a golden image or Ansible role so every new server starts hardened. Recap, baseline it, scan it, remediate it, verify it, and keep auditing. Congratulations, you have implemented global security guidelines on RHEL 10.